Hello student, now we will start the next topics of the limit, that is the method of substitution. That is, we will consider the examples of trigonometric functions in which x tends to a, where generally a takes the values such as pi, pi by 2, pi by 3, pi by 4, pi by 6, etc. In such a case, we put x is equals to a plus h as x tends to a, h tends to 0. For this, now we'll start the exercise 7.5. Evaluate the following. Limit x tends to pi by 2 cosec x minus 1 upon in bracket pi by 2 minus x bracket square. Now in this case also, if we substitute x is equals to pi by 2, that is a cosec 90, it's a 1 minus 1 0, and denominator is also 0. That is, we get the 0 upon 0 form, and that's why we make the substitution here. That is, the substitution is x is equals to pi by 2 plus h. Now see this here. Put x is equals to pi by 2h as x tends to pi by 2, h tends to 0. That is, put here L is equals to limit x tends to pi by 2 cosec x minus 1 upon pi by 2 minus x bracket square. Now in this case, we will put here, that is x is equals to pi by 2 plus h as x tends to pi by 2, then h tends to 0. The meaning of this is that here x is equals to pi by 2h. Here we substitute x is pi by 2. In place of x, there is a pi by 2 is equals to pi by 2 plus h. On both sides, pi by 2 get cancelled. It means h is equals to 0, and that's why we say that h tends to 0. Therefore, the first L is equals to limit x tends to pi by 2 cosec x minus 1 upon pi by 2 minus x bracket square is equals to limit h tends to 0. Now here variable is changed. Note this. And in this case, x is equals to pi by 2 plus h. Now see this here. Now see this here. That is pi by 2 minus x. Then you will get minus h bracket square. That is a cosec pi by 2 plus h. That is what is the sign of 90 plus theta is cos theta. In the same manner, the cosec pi by 2 plus h is sec of h. It goes in second quadrant. In second quadrant, the sign is positive. At the same time, cosec is also positive. One thing is that is a cosec pi by 2 plus h, we will get sec of h minus 1 upon minus h bracket square. Therefore, you will get limit h tends to 0 sec h minus 1 upon h square. That is, here we substitute. Again, I am showing this. X is equals to pi by 2 plus h. Pi by 2 minus x is equals to h. And by using this formula, that is a cosec pi by 2 plus theta is equals to sec theta. Therefore, limit h tends to 0, 1 upon cos h minus 1 upon h square. Now here we will simplify this. Then how it is? 1 minus cos h upon h square into 1 upon h, 1 upon cos of h. Now see this here. That is a 1 minus cos h upon h square into cos h. Now in this case again we have 1 minus cos h. That is a multiplied numerator and the denominator by 1 plus cos h. Then you will get 1 minus cos square h, then sin square h, and sin square h upon h square. The value is 1 square is 1. Now in this way we solve here. Now see this here. That is, here we multiplied numerator and the denominator by 1 plus cos h to the numerator and the denominator. That is, one thing is remaining, that is a limit as 1 upon cos h. That is, h tends to 0. The value of that is 1. That's why I have not written it. This is the 1 minus cos square h upon h square into 1 upon 1 plus cos h sin square h into limit, and the value of this limit is a 1 square into 1 upon 1 plus 1. 1 upon 1 plus 1 is a 1 upon 2. This is the L is equals to 1 upon 2. This is the answer. You can see. L is equals to 1 upon 2. Now next, example number 2, limit L is equals to limit x tends to a sin x minus sin a upon fifth root of x minus fifth root of a. L is equals to limit x tends to a sin x minus sin a upon fifth root of x minus fifth root of a. Therefore, we will write like this now. That is, here we apply the formula, that is a sin c minus sin d. That is a 2 times cos of c plus d upon 2 into sin of c minus d upon 2. Therefore, now here is that formula. Sin c minus sin d is equals to 2 times cos of c plus d upon 2 sin of c minus d upon 2. This is the formula. Now divide numerator and the denominator by x minus a. Therefore, limit x tends to a, that is a 2 times cos of x plus a, divide n and d by x minus a. And see this here. This is, that is, here we divided the numerator and the denominator by x minus a, that is a sin of x minus a upon 2 upon x minus a, the whole divided by x raised to 1 upon 5 minus a raised to 1 upon 5 upon x minus a. Now the same thing is here. Now see this here. That is a, we have this 2 to the numerator and we apply here to the denominator of the sin of x minus a upon 2. We write there. Now see this again. This is it. This 2 is adjusted here because the sine of theta upon theta, like that. That is the cos of a plus a upon 2 into 1. This is the 2a upon 2, that is the cos of a. Now the power of a is a raised to minus 4 by 5. It becomes positive when it comes to the numerator, and this 1 by 5 becomes the 5 here. Therefore 5 into a raised to 4 by 5 into cos of a, and this is the answer. That is a limit L is equals to 5 a raised to 4 by 5 into cos of a. Now the next problem number 3. Limit x tends to pi in root of 5 plus cos x minus 2 upon pi minus x bracket square. Limit x tends to pi in root of 5 plus cos x minus 2 upon pi minus x bracket square. Here is also as x tends to pi by 2 and cos of pi is minus 1. 5 minus 1, then you will get 4. Root of 4 is 2. 2 minus 2 is 0. And again to the denominator pi minus pi, that is also 0. That is a 0 upon 0 form. And that's why it is indeterminate form. And that's why we take the substitution. Always write this is the dialog. That is a x is equals to pi plus h. As x tends to pi, h tends to 0. Therefore, we'll write here limit h tends to 0 cos of pi plus h. Now see this here. Limit x tends to pi. Limit h tends to 0 in root of 5 plus cos of pi plus h minus 2 upon minus h bracket square. Now the value of pi minus x. Pi minus x is minus h, and that's why we get here in root of limit h tends to 0 in root of cos of pi plus h. Now the cos of pi plus h, it goes in third quadrant, and cos of pi plus h is minus cos of h minus 2 upon h square, and therefore cos of pi plus h minus cos h. Now here cos of pi plus h is equals to minus cos h is goes in the third quadrant. Limit h tends to 0 in root of 5 minus cos h minus 2. That is in root of, now this is, that is we rationalize here. Multiply the numerator and the denominator by the in root of 5 minus cos h plus 2. 5 minus cos h plus 2 in root of, and that's why you will get limit h tends to 0. 5 minus cos h minus 4. That is a square of this quantity, square of the 2. Therefore, limit h tends to 0, 1 minus cos h upon h square in root of, this is, that is a 5 minus 4 is a 1, 1 minus cos h upon h square in root of 5 minus cos h plus 2. Therefore, limit h tends to 0, 1 minus cos h. Now here again we have 1 minus cos h. We will not apply the formula. That's why we get the fraction there. That is a 2 sin square h upon 2. To avoid this fraction, we multiply numerator and denominator by 1 plus cos h. Now see this here. That is, that term is outside this bracket. Now see this here. That is 1 minus cos h into 1 plus cos h. This is multiplied at the same time. It is divided here. Again, in root of 5 minus cos h plus 2. Now, if we take the limit of this, that is as h tends to 0, that is the cos of h is 1. In root of 5 minus 1, that is a 4. Root of 4 is a 2. 2 plus 2. that is a 4, and here is also 2, that is a 4 into 2, that is become 8, and that's why. Now see this here. Now here is a 1 minus cos h into 1 plus cos h, that is a 1 minus cos square h upon h square into the remaining terms. This is the, now 1 minus cos square h means what? Sin square h. Limit h tends to 0, sin square h upon h square. This is the first. Now next is in root of 5 minus cos h plus 2 into this is the value of the 1 square in root of 5. Now here when you substitute, as h tends to 0, cos of h, the value of that limit is 1. Now in root of 5 minus 1, that is a 4. Root of 4 is 2, 2 plus 2, 4. 4 into 2, that will become 8. See this here. That is equals to 1 upon 8, and hence the final answer is 1 by 8. Now the next example is example number 4. L is equals to limit x tends to pi by 6 cos x minus root 3 sin x upon pi minus 6x. Put x is equals to pi by 6 plus h. As x tends to pi by 6, h tends to 0. This is the substitution. Now next, limit h tends to 0. Now here we will replace x by h. The limit of x was h. Limit of x was pi by 6. Now the limit of h is h tends to 0. Cos of pi by 6 plus h minus root 3 sin of pi by 6 plus h upon pi minus 6 in bracket pi by 6 plus h. If we simplify this, then you will get minus pi plus minus 6h. That is the limit h tends to 0. Now we will expand here. That is the cos of pi by 6 plus h minus root 3 sin of pi by 6 plus h. Now we will simplify here separately. Now what is the formula for the cos of a plus b? Cos a cos b minus sin a sin b. This is the first. Minus root 3. That is a cos of a plus b is a cos of pi by 6 into cos h minus sin of pi by 6 into sin h minus root 3. Sin of a plus b, that is a sin a cos b plus cos a sin b. And we will substitute here. That is a root 3 upon 2 into cos h minus sin of pi by 6. Sin of pi by 6 is minus 1 upon 2 into sin h minus root 3. That is sin of pi by 6 cos h. Now the screen is moving up and down. See this here. That is cos of pi by 6, which is the root 3 upon 2 cos h. Sin of pi by 6 is 1 upon 2 sin h minus root 3. Sin of pi by 6 is 1 upon 2 cos h plus cos of pi by 6 is root 3 upon 2 into sin h. Now multiplied with by the root 3, then simplify. Root 3 upon 2 into cos h minus 1 upon 2 sin h minus root 3 upon 2 cos h minus root 3 into root 3, that is a 3 by 2 sin h. Now these two terms will get cancelled. That is a root 3 upon 2 cos h minus root 3 upon 2 cos h. Plus and minus get cancelled. Minus 1 upon 2 sin h and minus 3 by 2 sin h. That is a minus 4 by 2 sin h means what? Minus 2, you will get minus 2. This is the simplification, that is minus sin h. Now we'll substitute in our example, that is limit h tends to 0 minus 2 sin h upon, this is the simplification, plus pi minus pi get cancelled, and then you will get, that is a 2 by 6 limit h tends to 0 sin of h upon h. The answer is 1, limit is 1, therefore 2 by 6 into 1, that is a 1 upon 3. Therefore the value of this limit is 1 upon 3. Now the next example, that is the limit x tends to 1, 1 minus x square upon sine of pi x. Put x is equals to 1 plus h as x tends to 1, h tends to 0. Therefore limit h tends to 0. Now see this, x tends to h tends to 0. So first replace x by h. 1 minus x, the value of x is 1 plus h bracket square upon sine pi in bracket 1 plus h. Now multiplied with, that is the limit h tends to 0, 1 minus in bracket, that is 1 plus 2h plus h square, open the bracket, then you will get sine of pi plus pi h. Therefore simplify, limit h tends to 0, sine of pi plus pi h is minus, this is the formula, that is sine of pi plus theta is minus sine theta, it goes in third quadrant, and in third quadrant sine is negative, therefore it is a minus sine of pi h. Therefore take the h as common. Now numerator and the denominator has the negative sign, it becomes a positive. Limit h tends to 0, h upon sine of pi h into 2 plus h. Limit h tends to 0, pi h upon sine into. Now what is here? That is h upon sine of pi h. That is a pi h upon sine of pi h into 1 upon pi into 2 plus h. As h tends to 0, that is a 2 plus 0, which is the 2. Therefore, this is the value of this limit is 1 into 1 upon pi, as h tends to 0. Therefore, you will get 2 plus 0 is a 2, and therefore final answer is a 2 by pi. Therefore, 1 into, this is as h tends to 0, pi h tends to 0. Therefore, the answer is 2 by pi. Therefore, L is equals to 2 upon pi. Now, next is question number 2. Evaluate the following limits. X tends to pi by 6, 2 sin x minus 1 upon pi minus 6x. Put again x is equals to pi by 6 plus h, as x tends to pi by 6, h tends to 0. Therefore, limit h tends to 0, 2 times sine of pi by 6 plus h minus 1 upon pi minus, this is, that is a 2 sine of pi by 6 plus h minus 1 upon pi minus 6 in bracket pi by 6 plus h. Therefore, we will get expanded. This is, now again we will see this. Again one thing, now this is the expansion, sine of pi by 6 into cos h plus cos of pi by 6 into sin h, bracket complete minus 1. and to the denominator pi minus 6h. Now that is a limit h tends to 0. That is a 2 in bracket 1 upon 2 cos h plus root 3 upon 2 into sin h minus 1 upon minus 6h. Now their simplification. That is multiplied this 2 to the 1 upon 2 and 3 by 2. Then you will get 2 into 1 upon 2 into cos h plus 2 into root 3 upon 2 sin h upon minus 6h. That is these 2 get cancelled and you will get cos h plus 2 get cancelled root 3 sin h minus 1 and this is. Now next is cos h plus root 3 sin h minus 1 upon 6h next is, I think that there is a minus 6h and in the next that is a root 3 sin h upon minus 6h plus cos of h minus 1 upon minus 6h. Therefore, the first limit is minus root 3 upon 6 into limit h tends to 0 sin of h upon h plus limit h tends to 0. I will take their minus sign as a common. Now the limit of this is, now this 6 can be written as 2 into 3 that is it. Then minus and minus that will become plus sin of h minus minus will become plus 6h multiplied numerator and denominator by 1 plus cos h, and that's why minus 1 upon 2 root 3 limit h tends to 0 and overall then we have to adjust here, that is a multiplied and divided by 1 upon multiplied and divided by h, that is this h becomes h square into h here to the numerator, and the value of this limit is 1. But as h tends to 0, this is the numerator is 0 and overall the value of this quantity becomes 0. Therefore, the answer is L is equals to minus 2 root 3 now once again see this whole answer. You can write now. In this way, the answer is L is equals to limit is equals to minus 1 upon 2 Example number 2. L is equals to limit x tends to pi by 4 root 2 minus cos x minus sin x 4x minus pi bracket square. Now again put here x is equals to pi by 4 plus h as x tends to pi by 4, h tends to 0. Now we'll find the value of cos x plus sin x. Put the value of x is pi by 4 plus h. This is the therefore substitute the value 1 upon root 3 cos h, 1 upon root 2 cos h, minus 1 upon root 2 sin h, plus 1 upon root 2 cos h, plus 1 upon root 2 sin h, and in this. Now here is a minus 1 upon root 2 sin h plus 1 upon root 2 sin h get cancelled. 1 upon root 2 cos h plus 1 upon root 2 cos h, that becomes 2 times. That is a 2 cos of h upon root 2. That is a 2 cos h upon root 2. Therefore root 2 cos h. Therefore sin x plus cos h is equals to 2 cos of h. Therefore L is equals to limit h tends to 0 root 2 minus cos x plus sin x upon this is our limit. Now we'll substitute h tends to 0 root 2 minus root 2 cos h, and the denominator is, this is the substitution. X is replaced by h plus pi by 4 minus pi. Now if you multiply with that is a 4, then you will get pi minus pi. Pi minus pi is 0, that is a 4 pi. Take the root 2 as common, 1 minus cos h, 4h, plus pi minus pi get cancelled, 4h bracket square, it is a 16h square, that is a root 2, 1 minus cos h, and that's why you will get 6 root 2 upon 16, h tends to 0. This is the, you can see again. Upon h square. Now again multiplied numerator and denominator by 1 plus cos h. Therefore you will get, that is a 1 minus cos square h upon h square. Cos square h upon h square into 1 upon 1 plus cos h. Now 1 minus cos square h means what? Sin square h upon h square. The value of this limit is a 1 square into 1 upon 1 plus 1, that is a 1 upon 2 into 1 upon 2 into root 2 upon 16, that will be the overall, that is root 2 upon sin square h upon 1 upon 1. Therefore now the simplification is, that is root 2 upon 32, 16 into 2. Therefore this is the answer. L is equals to 1 upon problem number 3. Limit x tends to pi by 6, 2 minus root 3 cos x minus sin x upon 6x minus pi bracket square. Therefore, you will get put x is equals to pi by 6 plus h. As x tends to pi by 6, h tends to 0. Root 3 cos x plus sin x, root 3 cos of pi by 6 plus h, sin of pi by 6 plus h. Now expand this. Cos of pi by 6 cos h minus sin of pi by 6 sin h, bracket complete, plus sin of pi by 6 sin h plus cos h plus cos of h cos of pi by 6. Now simplify this. It's a root 3 upon 2 cos h minus 1 upon 2 sin h. And next values are like this. Multiplied with root 3 to the whole bracket. That is root 3 into root 3. That will become 3. Root 3 into 1 upon 2. That is root 3 upon 2 sin h. These are 3 terms. Root 3 upon 2 sin h, root 3 upon 2, that get cancelled. 3 upon 2 cos h and cos of h upon 2, that is you will get 4 cos h upon 2, that is a 2 cos h. Therefore, the value is a 2 cos h. Therefore, limit x tends to pi by 6, root 2 minus root 3 cos x minus sin x upon 6x minus pi bracket square, limit h tends to 0, root 2 minus root, the value of that is in terms of h, that is a 2 cos of h. Again we substitute the value, that is x is equals to pi by 6 plus h. Simplify, that is a plus pi and minus pi get cancelled. Take 2 as common, bracket square, that is a 2 limit h tends to 0, 6h, plus pi minus pi get cancelled. Now multiply numerator and denominator by 1 plus cos h. Multiply numerator and denominator by 1 plus cos h. And that's why 2 limit h tends to 0, 1 minus cos square h upon h square upon 1 plus cos h, sin square h upon h square, sin square h upon h square into 1 upon 1 plus, that is a 1 upon that is equals to 1 upon 36. Therefore, L is equals to limit is equals to 1 upon 36. This is the answer. Now next, problem number 4. L is equals to limit x tends to a sine of root x minus sine of root a upon x minus a. Now the limit x tends to a sine of root x minus sine of root a upon root of x bracket square minus root of a bracket square. We can write. Here is x minus a, and x minus a can be written as root x bracket square minus root a bracket square. That's why limit x tends to a sine of root x minus sine of root a upon root x minus this. That is into 1 upon root of x plus root of a. Now we will take the next limit into limit, that is a limit x tends to a 1 upon root x plus root a, that is a 1 upon 2 root a, that is sine of root x minus sine of, that is 1 upon 2 root a, limit x tends to a sine of root x minus sine of root a upon this. Now we'll make their substitution. Put root x is equals to y and root a is equals to b. Therefore, as x tends to a, y tends to b. Therefore, one upon 2 root a limit y tends to b, y is equals to b plus h. Therefore, 1 upon 2 limit h tends to 0. Sin of b plus h minus sin of b upon h. Now here we will apply the formula for sin c minus sin d. That is 1 upon 2 root a limit h tends to 0. See this again here. That is a 2 times cos of a plus b upon 2 into sin of a minus b upon 2. Now b plus b is a 2b plus h upon 2. Sin of bb get cancelled here. It is h upon 2 upon h. Now next is, here is again, that is a cos of 2b plus h upon 2, and this 2 is adjusted here. That is a sin of h upon 2 upon h upon 2. That is a 1 upon 2 root a. That is, if you take this limit, that h tends to 0, then you will get 2b upon 2, and the limit of this sin of h upon 2 upon h upon 2 is 1. That is 1 upon 2 root a into cos of 2b upon b, 2. That is a cos of b, you will get cos of b. Therefore, 1 upon 2 root a into cos of b, that is a cos of b upon 2 root a. And therefore, this is the limit. Therefore, L is equals to cos of root a upon 2 root a. Now, the next problem is fifth. That is the limit x tends to pi by 2 cos of 3x plus cos of plus 3 cos x, cos of 3x plus 3 cos x upon 2x minus pi bracket cube. Now here we apply the formula. I am writing both the formulas. That is, the sin of 3x is equals to 3 sin x minus 4 sin cube x, and cos of 3x is equals to 4 cos cube x minus 3 cos x. By using this formula, that is 4 cos cube x minus 3 cos x plus 3 cos x. That we substitute the value of cos of 3x here. That is 4 cos cube x minus 3 cos x. Now here is a minus 3 cos x and plus 3 cos x get cancelled. Therefore, you will get limit x tends to pi by 2, 4 cos cube x upon. Now put x is equals to pi by 2 plus h, as x tends to pi by 2, h tends to 0, limit h tends to 0, 4 cos cube in bracket pi by 2 plus h upon 2 in bracket pi by 2 plus h minus this is the. If you multiplied it, then you will get limit h tends to 0, 4. Now what's happening here? That is a cos of pi by 2 plus h. It become minus sin h, and minus sin h into minus sin h into minus sin h. That is a 3 times. And overall it becomes minus sin h here. Therefore, limit h tends to 0, minus 4 sin cube h upon. This is the simplification. If you multiply it, then you will get pi plus 2h minus pi plus pi minus pi get cancelled. Therefore, limit h tends to 0, minus 4 sin cube h upon 8h cube. That is equals to minus 1 upon 2 Limit x tends to 0, sin cube h upon hs cube. Therefore, the value of that answer is minus 1 upon 2. And in this way, we have completed this exercise. Now we'll see in the next video. Till then, goodbye.